Welcome to another virtual Live Talks Los Angeles event. We welcome Bill Nye and Gregory Mone to our series. We invite you to visit our YouTube channel for over 300 conversations, much like this, including 2 previous interviews with Bill Nye for 2 of his earlier books. Today we talk about their book, Bill Nye's Great Big World of Science. Bill Nye is the New York Times bestselling author, mechanical engineer, and television host, best known for his television show, Bill Nye the Science Guy. Gregory Mone is a New York Times bestselling author and science journalist who has written several books for children, including the Jack and the Geniuses series, co-authored with Bill Nye. Welcome again to both of you. The book has terrific images. It's so beautifully designed. It's got facts, and even though it's packaged as one for young readers, I learned so much for it. So let's do this. I'd like to start with you guys telling me how does a book like this come together? Who wrote what?
Well, it starts in a golf cart, right, Bill?
Yeah. It just takes a few minutes, really. No, it's a huge amount of work. So the way I describe this is the book I always wanted to write. And we say in television is words and pictures. This book is words and pictures, and I just think it has a completeness for middle school people and a lot of people that my other books, or Greg's and my other books, didn't do. So I'm just really happy about it. So how did it come up, Greg? Abrams said, "Hey, do you want to write another big book?" And I said, "Well, if Greg's involved, maybe."
Well, something like that. I mean, Ted, first of all, I always think this is kind of funny, but Bill and I actually met out there in LA. I'm now on the other coast. I wish I was out there with you guys. But we met in a coffee shop very randomly at a Coffee Bean and Tea Leaf. I was out there reporting a story for Popular Science, and one thing led to another, and we went surfing together, and that was a pretty fun experience. And Bill was out there talking about the physics of the waves the whole time, and weather and climate.
I can't surf, but Greg is an excellent surfer.
Yeah, but then we ended up coming up with this other book idea, this series, Jack and the Geniuses, about these 3 kids who use science and tech to solve mysteries. And then we had a lot of fun working together, and Bill had this thought, and Bill and our publisher, we started talking. We said, hey, let's jump back into nonfiction and let's do something bigger. And then it was just a question, Bill, right, of what's going to go in here, So that's kind of where we started. Is it's pretty hard to write a book just about science. And so I know there were a few obvious ones, but then one that would surprise me, Bill, was you definitely wanted tribology in there, and you.
I love tribology.
So explain that a little bit.
Tribology, everybody, is the study of friction. So it's really, it might be something you take for granted. If you've ever heard basketball shoes on the floor squeaking, if you've ever seen people, you ever take off your shoes, run down the hallway in your socks and slide, or if you've ever been in a car that goes around a corner, you got to have some friction, or it's going to be trouble. But here's a cool philosophical question, my friends. Roads are made of concrete. They're made of solid rock. Tires are made of rubber, which is soft. So how does a soft rubber tire ever wear out the rock hard street? Whoa. That's tribology.
But we also focused on kind of how to organize the book in a larger way, and we definitely wanted, and Bill, you had this idea. Bill's very into kind of organizing principles for any large project and how to set everything up and how it's all laid out and organized into sections. And so you had an idea for kind of 3 overarching large sections, right? And we might have mixed it around a little bit in the finished book, but that helped us kind of get started.
Well, the big thing, when you're going to write a book about science, is what are you going to leave out? But I start with, from the Science Guy show days, we start with 3 big ideas: life science, which you might call biology; Then physical science, which is physics and chemistry, the study of motion and the motion of molecules and how they interact. And then what I like to call planetary science. So I'm speaking to you today from my office at the Planetary Society. These are autographs from people who have come to visit. And planetary science for me includes planets, and that includes Earth, and it includes the stars and outer space and black holes, and now dark matter and dark energy and all these things that we're just beginning to understand in science. So you start with those three, and then you can break those down. Life science can be plants, animals, humans, physical science, physics, and chemistry. Then you get into thinking. I was in a meeting with some people who were really good friends of mine. This is several years ago. And I said, well, so-and-so's a geologist. And then Bruce Murray, who had been the head of the Jet Propulsion Lab, said, he's not a geologist, he's a geochemist. Whoa, excuse me. So you can break it down even more if you want. And then in planetary science, you got astronomy, astrophysics, the study of black holes and the nature of space, and then relativity. And so anyway, working with Greg, we took the big ideas and chopped them up, divided them until we got a series of chapters that I'm just really proud of and really pleased with.
But it's funny because as we were working through all this and trying to come up with these different pieces, you know, we spoke to a ton of scientists and interviewed them to kind of get their ideas on what they thought should be in the book. And, you know, at one point we had a chapter just solely focused on the moon because I didn't know, but there's a whole field, selenology, or is that how am I pronouncing it?
Selenology begins with
right, but
it's from it means, well, it doesn't begin with a C like you might think.
Right, but then when we got down and started talking about the other moons in the solar system, which are absolutely fascinating, you know, like Europa, all of a sudden it started to feel like maybe our own moon didn't deserve its own chapter just because it's up there and we see it clearly. And so we folded it into these other ones. And, you know, but some of this stuff, I mean, that piece of the book, I've been writing about science, you know, for a long time, but that piece where we were kind of talking to all these scientists about the different moons and planets, it just made you want to write. I mean, you could write a book about each one. Like I see over your shoulder there, it says Titan or bust, you know. I mean, every planetary scientist probably has a different idea about where they want to go next, you know. I mean, do you have a favorite, Bill, like a favorite destination or?
I am very excited about two missions. The first one, well, by the way, while we're sitting here, yesterday, OSIRIS-REx scooped up, except in outer space, there's no sound, scooped up a few hundred grams of asteroid Bennu. And the name Bennu was given to it by a guy named Mike Puzio, who was a kid. He was in third grade when he came up with that name. This is a Planetary Society contest. And yesterday we scooped up a piece of asteroid. We scooped up a piece of ancient solar system. But for me, I want to go to Europa. This is a moon of Jupiter with twice as much ocean water as the Earth. And if you have ocean water for 4.5 billion years, is there something alive there? Are there some Europanian microbes? Are there Europanian fish people swimming around making jokes about the sky being made of ice? Let's see.
Wearing bow ties, maybe.
Yeah, right here. This is one of these is by Emily Lakdawalla. If you're a Planetary Society member or reader of the website, she's a very popular journalist who's all about Europa and all the moons in the solar system. And then the other place, you guys, 2 weeks ago, people discovered phosphine gas, whatever the heck phosphine is. Phosphine is just like ammonia, which is nitrogen and 3 hydrogens, but it's phosphorus and 3 hydrogens in this kind of triangle, shallow pyramid shaped molecule. The only way we know to get phosphine on a planet that's as small as the Earth is with living things, microbes that exhaust or respire phosphine. So wait a minute. Are you suggesting that life started on Venus 3.5 billion years ago. Venus became uninhabitable on the surface because the greenhouse effect ran away. More carbon dioxide made the planet warmer. More carbon came out of the rocks, literally, and bonded with atmospheric oxygen and turned the whole place into this super hot place, except the atmosphere at a certain altitude of Venus is still the right temperature for the microbes that live there 3.5 billion years. What? That's a hypothesis that you right now cannot dismiss. It's extraordinary and wild and hard to believe, but it's worth investigating. Europa Venus, that's what I'm going, that's what I'm into. And I want to go to Titan. Hey, don't get me wrong. I'm a longtime member of a society as the principal investigator of this mission to Titan. Oh, it's going to be so cool. So yeah, there's so much going on in outer, with all the stuff that's going on Earth right now. Wow. But outer space is still, we're chugging away out there.
Yeah, and it's, that was the other piece of that section of the book is, talking to planetary scientists about these different moons and planets, and then speaking with astrobiologists, these people who are trying to figure out how life could develop and survive out there in the solar system and beyond, what conditions it would need, what sort of parameters. What it makes you do is it makes you think, geez, for all of our problems, we live on a pretty cool planet, and yeah, it is a pale blue dot in the middle of nowhere, but it is an amazing, special place. And, and we do have, we sort of we didn't just do an Earth chapter, right? We have a chapter on different kinds of geology. I think we initially called it rocks, and then we decided maybe that wasn't too inviting. but then we got oceanography, talking about how the world's oceans work, and then we have one specifically on hydrology, which again I didn't think was going to be super exciting or interesting, and it turns out it's absolutely fascinating.
And if you're a kid looking to go into a profession, hydrology is certainly something to think about, because the water is going to be the world's next oil. And I mean, it's going to be so important as we go from 7.7 billion to 9 or maybe even 10 billion people. Everybody's going to want clean water. And our agriculture, all the food that we eat, depends on sources of non-salty water. So if you want to go into hydrology, way to go.
Yeah, so one of the pieces there, and I thought this was fascinating, is like they were talking about in California where you live, there's one hydrologist we interviewed, actually two of them were both talking about this, how just the changing weather patterns and not having sort of consistent snowpack throughout the year changes the way water comes down to Southern California and the rest of the coast. And so that then becomes an engineering problem, right? If water's coming down in different ways, how do we collect it and move it? Is that, am I characterizing that right? Or
how do you manage enormous amounts of water to irrigate crops and give people water to drink? It's a huge problem. And you think it's not solvable. You might think it's overwhelming, but man, what humans have done to manage water is really impressive. The dams, hydroelectric dams, and the aqueducts, the water carrying human-made streams are just amazing. There's a thing called the California Aqueduct. If you've ever been in an airplane, back when people used to get on airplanes, you can see it just plain as day. It's just this huge system that irrigates all this farmland. If you live west of St. Louis, maybe, you eat California. If you live back east, you eat California raised produce all the time because there's so much sunlight. And if you can get water there, the soil is very good for growing crops. Now, speaking of hydrology, we do extract a lot of water in the Midwest from the Olagala aquifer, and we can't do that indefinitely. We're draining the aquifer. But if we can figure out how to economically take salt out of seawater, we'll be set. And I look over my shoulder there, Greg, the blue one, the first Jack and the Geniuses book that's the premise, is the kids who live without parents in some remarkable way because they got rich by writing poems and distributing a video where he does CPR on a puppy.
Yeah, totally makes sense. I mean, that's what happened. That's the way the world works. Yeah.
They find a new way to desalinate water, seawater. So I mentioned that as just a cool idea. And what makes you and I possible, by that I mean big living things who live on land like us possible, is the ocean. If you live in, what did I just say? The middle. If you live in Nebraska, about a third of the oxygen, at least a third of the oxygen you breathe is produced by tiny plants, phytoplankton in the ocean. If you live in Florida or California, almost all of the oxygen you breathe comes from the ocean. And so the reason the ocean is able to support so many living things to produce so much oxygen is it moves. The ocean has currents. That's the key. It moves plant fertilizer all over the world. And so we have a description of that I'm really proud of. You talk about the arrows, Greg.
Yes, Bill was very into the arrows and making sure they curved the right way and they had the right directions, all of it, But those are really important points. I mean, the idea, even just the idea, you hear a lot about microplastic pollution these days, and it's hard to fathom, but true that, if you throw a fleece jacket in your washing machine in the Midwest, that water is going to run out and it's going to get into a river and feed to a larger river and eventually get out of the ocean and go all the way out to the middle of the ocean. I mean, scientists have tracked this stuff and it's absolutely incredible. Now, one of the other funny things I liked about, doing the research for the book, and we ended up talking to 75 different scientists and interviewing.
You did the heavy lifting on that, my friend. Yeah.
Well, and so in talking to all of them, I love the little side stories too, and the anecdotes about, the history of their field. So for instance, one of the hydrologists was telling me that, one of the people who's considered one of the first hydrologists was this French guy, Perrault, whose brother wrote the Mother Goose series.
Yeah.
And he was some kind of tax collector for Louis XIV. And eventually, I think it was the 14th, maybe it was a different Louis, the big hair, one of those guys. And at some point the king decided, I'm not going to collect taxes anymore. So this guy was out of a job and he decided to study the Seine, the river, and figure out where the water was moving and how. And all of a sudden became, the first European hydrologist. That kind of stuff, and the book is filled with scattered facts like that. But I got a real kick out of that.
Well, it's amazing, and the other thing I really hope people get, and I wrote the introduction, and Greg can give you an earful about the introduction I wrote, but just that we're constantly learning new things. That's the process of science. And so what I want everybody to embrace is that it's going to change. The number of moons of Jupiter is going to change. We're going to find more or prove that there are fewer or something. And so when I think about this hydrologist studying the flow of the Seine River through Paris, without that guy's research, we wouldn't be able to run the country of France very well. We certainly wouldn't be able to run farmlands. And so we're learning new things all the time, and I'm just overwhelmed. I mean, yesterday, picking up pieces of an asteroid, and then a couple of weeks ago, discovering phosphine gas in the atmosphere of Venus. And, when I was a kid, there were fewer than 3 billion people in the world. Now there's 7.7. There's going to be 8, 9, maybe even 10 billion people, and they're all going to want something to eat. And we're going to provide them food because of our understanding of the science of agriculture, the science of farming. And we're going to learn new things between now and whoever's going to read this book. And when that person goes out into the workforce. So I'm excited about it.
And the other piece with that is, we've talked about this before, Bill, but when you talk to scientists who are out in the leading edge of these fields and they tell you sort of what we still don't know. They don't say it, you know, when a little kid says they don't know something, or one of my kids, you know, I don't know, it's like a heartbreaking, disappointing thing. I don't know that, you know, versus when you hear it from a scientist, it's excitement, right? It's here's an unknown question we haven't found the answer to. And I found 5 new questions this year. And so sort of that, I hope we get that across in the book, you know, that piece of science where not knowing and sort of having these open questions is tremendously exciting.
It is. Science is exciting, people. Nothing cooler. No, really.
You know, and the other piece, the other one of the running themes in the book is, you know, and you were very keen on this, Bill, is, and I don't know if this goes back to the show or this is something you picked up later, is sort of reminding kids that they can be scientists today, right? And so you mentioned the example of, right, a kid who names Bennu, you know, and then we have another example of a girl who I think she spotted a supernova or something like that. But you know, and we're not making this up. These are 12, 13-year-old kids who are spotting things and you know, and doing amazing things. And maybe you're not finding, you know, a supernova, an exploding star, but maybe you're just observing something in your backyard. You know, we talked to animal biologists who are saying, hey, put a camera on your window, see what comes up to get it. So, you know, but that idea of, you know, kind of getting kids to think about themselves as scientists today, why was that important to you?
Well, we want everybody, the modern phrase, and it's a fine one, we want everybody to have so-called critical thinking skills. And it used to be, I don't know what it used to be called, logical reasoning or something. You just want everybody to be able to evaluate evidence. When somebody tells you something, you have to, is that true? I'm not sure. We want everybody to have that skill. And we want also on everybody to have the so-called habit of mind, not just of questioning things or asking questions, but coming up with hypotheses or ideas of why something happened. So when you put that food out to see if a bird or a rat, or not a rat, a mouse comes by, you have a hypothesis about what's going to happen. And then you observe it, and then you compare what you thought would happen with what really did happen. And then you start over. And we want everybody to have a feeling for that process. And we don't want everybody to become a scientist. We need everybody to do, we need people to lay bricks. We need people to write laws or argue about laws. We need people to make coffee. We need everybody. But we want everybody in our society to be able to think scientifically. And so that's a dream, that's a hope. And the book, I hope is not a plan, but nevertheless, I'm hopeful the book inspires somebody to think scientifically. And we have a little mention, Greg, thanks to you, of the old Tree Octopus, of which I'm a huge fan.
Yeah, so I don't know if everyone's heard that story, but this is actually you know, but it's a good one. And it actually relates to this book. We were kind of struggling to make progress, and you know, because it's big and we're trying to figure out how to do it. So we said, all right, let's all meet. And this was back in the day and age when people met in a physical space, in the same space. And so Bill and I and our editor got together in a conference room, and we started digging in and hashing out what we wanted to be in the book. And then our editor sneaks away at one point, and Bill says, Greg, I tell you what's got to be in the book, the Tree Octopus. And I'm sitting there. Bill Nye knows a lot of stuff, and you know, there's a lot of things going on in his brain. So I think I've never heard of a tree octopus, but this is Bill, and so I don't want to look like I don't know what it is. So I start nodding along seriously, and he slides his computer over to me, and he types something in, and he shows me this website, and I'm looking at it thinking, what's going on here? And then I see Bill laughing, and I start to realize, that there's something else to this tree octopus thing. But I would encourage parents and kids to Google that, because it turns out it's an absolutely fascinating experiment on internet research and sort of critical thinking and all these different pieces. So It is in the book, but not in but in a kind of surprising way.
Yeah. And the gal, I don't know who wrote most of the pages of the Tree Octopus websites, but I could not help but notice that Nalini Nadkarni, who's a woman who studies epiphytes. These are plants that live in the trees, in the canopy of a forest, but their roots never touch the ground. Whoa. And I wouldn't be surprised if she was involved in that Tree Octopus thing. I wouldn't be surprised, but she just won a big award and it's deserved. She's really a character.
Oh, that's cool.
She lives for part of the year 150 feet off the ground in the Amazon or in the Pacific Northwest, wherever there's a huge forest. She's quite a character.
Wow. You know, and it's funny, the botany chapter was one of the chapters that I wasn't particularly excited about researching. And then we dug into it, and it was absolutely fascinating. And again, you know, speaking to botanists, you realize, who are obviously clearly passionate about their field, you realize what an enormous role plants play in our world. And then, you know, and then there were other little fun insights. Like there was one botanist, Ihan Tan, I think he's at the University of Maine, and he said, well, you know, people get so worked up about mammals and big creatures, but mammals, they're weak. They require all this care and feeding as babies, and seeds. We could put a seed away for 10,000 years or more, and then grow it again with a little soil, a little water, and a little sunlight. So that kind of perspective, I think, was really helpful. But then also just the, you know, understanding the kind of larger contribution of plants to our planet, right? I mean, I know that sounds simple, but
well,
yeah, it was very.
Be here without plants. We depend on plants. Right? Without plants, there's no people. So, and Greg, as you pointed out, so the book has what, about 30 demonstrations or home experiments.
We have quotes, direct quotes from the scientists throughout the book, and some of them are kind of mind-blowing, and some of them are a little bit funny. Well, you know, there was a botanist, I believe it was Sharon Robinson, I could be getting that wrong, but she said, she was very blunt at one point in her quote. She said, well, hey, without plants, we'd all be dead. You know?
You got a problem? Because they'll
exactly. Now, Bill, obviously, so we spent, it took us about 2 years to write the book in all. You know, we probably spent a year researching and then a year just hammering down the words. And it really was truly collaborative in the sense that, you know, every passage was gone over multiple times by each of us, you know. Yeah, and you know, and every page in the book, you know, and it's a big book and it's pretty, but you know, every single page it probably has 3 to 4 separate stories or ideas on the page, and each one of those we churned over multiple times. Now, there are a couple things that I kind of, you know, went hands off on, and one of them was the introduction, and that was mainly because, you know, Bill was very passionate about these ideas. He said, no, I got this, you know, and it was good, you know, and I like it. There's some really inspiring thoughts in there. And the other one was the periodic table.
Oh, yes.
Now tell me, why are you so excited about this periodic table, and why did you put so much hair-pulling effort into it?
Well, I spent a lot of time with periodic tables as a mechanical engineer. And my grandfather was a chemist, and so on. I just claim that this periodic table is the most useful version of the table you're going to find if you're in middle school or high school. It has the information you need without too much more information. And the idea behind the periodic table, you guys, or this Dmitry Mendeleev is sitting there thinking, you know, I predict that check it out. I'm sitting in my office with motion sensor lights, and I've been sitting still so long, the lights just went out. Whoa, dude. So if I wave my arms, it'll come back on. I think it will. Let's see. Yes, there we go. So
I feel like that was working though, because it's almost Halloween here, you know?
Maybe
a little spooky.
Or it'll turn off again, I guess, in a few. But he predicted that these elements would be found, and he predicted their melting points. I mean, people, what? he predicted that metals would be found, and then they were found, and he predicted. That's amazing. And, we all talk about salt, and it's just time and noble guesses. Here's helium, and you might have xenon light bulbs. You may have heard about radon in your oxygen. We breathe it. Carbon is what so much of ourselves are made of. And then nitrogen is 70% of the air between you and your laptop or your computer screen. So it's just an important thing for people to think about, is the relationship of all the different elements. And so thank you, Greg, for your patience on that. So it's a fabulous part of it.
It is a good part. Now, did you, again, the other piece that I had less of a hand in was the experiments, which is really Bill's sort of wheelhouse, very passionate about demonstrations and experiments.
You had your kids try them, right?
Yes, yeah, no, totally. I mean, and we made a mess of our kitchen, and and one of my favorites is one I tracked down from JPL, the Jet Propulsion Lab, which kind of helps explain dark matter, which has always puzzled me, but it involves, I won't give too much away, but it's very simple, and you won't make a mess of your house. It involves some mason jars, some spare change, and a little bit of water. But Bill, when I brought that to you, you were like, yes, I want that in there. So why did that one in particular excite you?
So you guys, let's let our story begin a little over 100 years ago. My grandparents grew up as from kids to adults with no idea that there was such a thing as relativity, that the speed limit of the cosmos is the speed of light, and that if you go at extraordinary speeds near the speed of light, as many stars do relative to each other, all kinds of crazy things happen with time. If you have a mobile phone, it depends on both special relativity, the speed of the satellites relative to the Earth's surface, and general relativity, the gravity of the Earth affecting the speed of clocks on the spacecraft. Like, whoa. Well, anyway, they grew up, saw nuclear energy discovered, saw nuclear weapons, got electricity from nuclear power plants, the discovery of the neutron, for example. Like, wow, they lived through all that. Well, now it's becoming clear that we don't know what almost all of the universe is. And you'll talk to different astrophysicists. Some people say 94%, some to 95%, some 96%, but some about 95% of the universe. We don't know what it is. And this is this dark matter, which is moved around somehow by dark energy, or is related to dark energy. So the demonstration that Greg's talking about, which we got the idea for, or we were shown how to do it by a guy at Jet Propulsion Lab, is this thing that shows you the process that astronomers, astrophysicists use to understand what little we do know about dark matter. And that is the motion of the stars and galaxies cannot be explained without there being some source of gravity that we can't see, something pulling and tugging and nudging them in a way that we can't observe directly with telescopes of any kind, radio telescopes, optical telescopes, infrared telescopes. And so I predict that readers of this book will be around when some fundamental, amazing thing is discovered about dark energy and dark matter that may lead to practical applications as important as your phone and this Zoom call, this computer phone call. And so this demonstration that Greg's talking about shows you the motion of coins when there's dark matter and when there isn't. So it's a cool little demo that the guy at what's his name at Jet Propulsion Lab, Greg?
Chaz Shapiro.
Yeah, showed us, and he gave us permission to put in the book. It's really cool.
And this whole bit on dark matter reminds me of another story. And I'm at the point I don't even we had so much. At one point this book was, I think, 3 times the size it is now. So I don't even know what ended up in there anymore to some extent. But there was this, no, I do. But there was this story I remember reading about this astrophysicist Vera Rubin, who's, sort of one of the most important thinkers on dark matter and dark energy in the 20th century and today. I remember reading that she, at one point when she was a kid, she would sit up at night and look out her window at the stars. And she might have even made a homemade telescope with her father. And anyway, my point is, she started on that path as a 10 or 12-year-old, right? As a kid, she started looking up at that night sky and thinking, what's going on up there? Well, how does this work? And eventually, she was studying spiral galaxies and trying to understand dark matter that way. My point is, that kind of stuff, it starts now with the kids that are hopefully going to be reading our book. And as Bill said, we're not expecting, every single reader of this book to turn into a scientist, but we hope to inspire a few of them. And then we just hope to inspire kids to just be interested in science and the scientific way of thinking and looking at the world. Because I do think, whether they become lawyers or basketball players, it doesn't matter. That scientific way of thinking is just a really important, valuable piece of our society, right?
I say all the time, it's in the U.S. Constitution, the progress of science and useful arts. It's one of the jobs of Congress. Article 1, Section 8, Clause 8. But
not that, yeah.
I'm not a constitutional scholar, but I can tell you that's in there. So what we want is everybody to appreciate science, appreciate this process. And it's more important than ever. And then to your point about kids, when we did the Science Guy show many years ago, we had very compelling research that 10 years old is about as old as you can be to get the so-called lifelong passion for science. But I think it's about as old as you can be to get a lifelong passion for anything. Like, Greg, when did you want to tell stories? You don't remember, right? When you were
yeah, probably that age, yeah, or younger, yeah.
And after 10 years old, then you're in middle school, then you're able to reason as well as anybody, let me assure you, but you just don't have that life experience. And so the book, I hope, will give you, show you a way of thinking scientifically, give you demonstrations you do yourself. You can't beat that where you handle it yourself, and expose you to all these cool aspects and facts and wonderful stories in science that I think will just make your life more fun. So very excited about the book. Greg and I put our heart and souls into this thing. And I think there are 10 in the carton. They make great gifts. Coming up, traditional Halloween gift giving, like the holidays are coming up. And so no matter what age you are, I think there's something in here for everybody.
And I do think it is going to be, or I hope it'll be kind of a valuable addition to, this strange whole world of remote learning. Even as, my kids are right in the age range of this book. I've got a 10-year-old, a 13-year-old, and a 15-year-old. And, I know they don't want to read Dad's books anymore. What's that, Bill?
They used to be younger when we started working together.
I know they were younger when we started working together. But they all read these ones, and we're going to use it, and I'm going to make them read it, but they like it so far. And it's a great, not just doing the demonstrations and kind of doing science hands-on, but just open up to a random page, reading a little bit, and then sparking a little dinner table conversation, which has become, it's once again become a big part of our life, at least our home life, now that we're in this strange world of social distancing. Now, Bill, I know someone's probably going to want to know, we don't have direct questions right now, but someone's probably going to want to know how many bow ties you own.
Oh, about 500. I only wear one at a time.
Interesting.
I also have a policy, everybody. Whenever I wear a bow tie, I also wear a shirt. It's just
That was circling back to the beginning when we were talking about tribology and friction, and we did use the example of sliding across a floor and sliding across the floor with your socks on, we did make it clear in the book that you should also be wearing pants.
Yeah, you don't want to scare people, as you put
Right.
it.
Yeah. Now, do you quickly before, I know we're starting to wrap up here, but you are the CEO of the Planetary Society. I always picture CEOs as just going around in private jets. And what does the CEO of the Planetary Society do, sir?
It's so we are the world's largest independent space organization. We have 50,000 plus members around the world who think space is cool. And I like to say we do three things. We educate. We have a fabulous website. We have all these resources for learning about space. We innovate. In fact, I'll show you something in a second. And we advocate. I go back when you could go places. I go to US Congress with my colleagues and convince congressmen, senators, members of Congress to invest in space exploration, especially planetary exploration. And we would be this week at the International Astronautical Congress, which this year is would have been in the United Arab Emirates. And that's where we meet people from Japan, our colleagues in Japan, Denmark. Like this coffee cup I was using features the Mars 2020 rover. Well, I went to Copenhagen and met the guys who are designing the thing that the camera uses to get the colors of the rocks right. It's an international effort, space exploration. And then at the planetary side, we built our own spacecraft. Let's see, and that's LightSail 2. You can go to our website and follow it. Right now, it's there over the South Pacific or Mid-Pacific. And that's the next time it'll pass over here in Pasadena. And this is a spacecraft that was built with money or donations or support from our 50,000 plus members who just think it's cool. And we did 2 missions, LightSail 1, LightSail 2. We flew them for about $7 million. And estimates vary, but if you were to do it at a regular space agency, NASA or ESA, European Space, or Canadian Space, or JAXA, Japanese Aerospace Exploration, it would cost about 20 times that, 140, 150 million. So we're very proud of that. And then you guys, I just remind you, I do a podcast, Science Rules, and we do Science Rules Coronavirus Edition, where we have everybody in the epidemics business. We've had Tony Fauci on the show. We've had Michael Osterholm on the show. And just this business of wearing a mask is really real. Don't fool with this. You got to wear a mask. I'm in my office with the door closed, but you got to wear a mask when you're out in public interacting with people. And that's not magic, you all. It's science. And we haven't talked about germs in here. Oh, another thing I'm really proud of, Greg. Another thing I'm really proud of are the domains of life. So it's just quite a thing that we've discovered that the cell walls of bacteria are different from archaea. And you and I are eukaryotes because we have nuclei in our cells. And I'm very excited about the viruses, which in the plural would be a Vera, and I'm giving them their own domain of life. Perhaps a controversial point of view, science changes.
Yeah, and you know what? We talked about this recently, and my daughter was asked to write an essay about whether virus should be its own branch of life, and she said yes, and she got 100 on the essay. Damn.
So how old is she? I've lost track. Is she the 13?
This is the older one, the 15-year-old, yeah. But she still listens to me sometimes.
Yeah, but she's a little too cool for that, Dad. Okay.
Yeah.
Oh, you're on Facebook?
All right. Well, thank you, Ted. This has been fun.
Yeah, it's really cool. Thanks. Check it out. If you're at home, schooling at home, part-time at home, I think this will be a good, I think Greg agrees with me, it'll be a good resource for you. If you just think reading about science and making discoveries in the cosmos is cool, try that too.
Yes, sir.
Well, thanks a lot, Bill. It's great having you back on our series. We had you for two of your earlier books, and thanks, Gregory, for being part of the conversation. Thanks to all of you for joining us. Their book, again, is Bill Nye's Great Big World of Science. It is available wherever books are sold.